Hello everyone, very good evening. Let me check whether the audio and video is fine so that we can start the discussion. Cool. So let's start the class, and if you have any doubts you can just put it in the chat. Okay, so let's start with the discussion that what is the correlation of. Alright, so let's start the discussion. Hello everyone, very good evening. My name is Dr. Pooja, your own physiology faculty, and today we are going to discuss about the ventilation curve, right? That means what is the correlation of ventilation with oxygen, carbon dioxide, as well as the pH, right? So we are going to start. So let's talk about this. Before going to and jumping into the discussion, I want you to have the look on this question. So what is this question saying? In the following diagram, the curve X represents the normal relationship of alveolar ventilation with PaCO2 and when the PaO2 is 100 mmHg. So that what the examiner is saying is X. That means this graph over here, the end graph that is showing the graph with which when the PaO2 is 100 mmHg. PaO2 is 100 mmHg, right? But he's saying that if the pH is changed from 7.4 to 7.3, change in the alveolar ventilation will shift to which of the curve? Option is A, B, C, D, of course, right? So you have to identify that when the acidosis is going to take place in the patient, where the graph is going to shift. For that, we are going to draw this graph on our own. So let's see how this graph is going to look like when we are going to draw that graph on our own. So let's assume there is an X and Y axis. Let's assume that there is X and Y axis. So just give me a minute. So let's say this is the x-axis and this is the y-axis, and let's say at the bottom we do have PCO2 and over here we are writing the ventilation. What the two things I always tell you that first of all, whenever there is a curve which is of graphical representation, when there is a curve or there is a graph given, two things you have to do. First thing, don't get scared, and the second thing is look at the x and y axis, of course, right? So what is the x and y axis over here? X axis is PCO2 and ventilation. Now remember, there is something known as apneic point. The point that I'm drawing over here, it is not going to be a zero value. It is going to have the value. Usually the Genong and Guyton says that it is 37 mmHg. What is this 37 mmHg? It is the partial pressure of carbon dioxide at which what is going to happen? The partial pressure of carbon dioxide at which the apnea will occur. The apnea will occur, and this point will be called as apneic point. This point is known as apneic point. All right. So this point over here will be called as apneic point, where the apnea is going to occur. And normally what is that point, or when this point will come? Whenever the PCO2 is 37 mmHg. Fine G, I agree. But what if the PCO2 keeps on rising? So there will be a linear correlation of the PCO2 with the ventilation. That means the graph will look something like this. So let's say the PCO2 is rising. The graph will look something like this. That means there is a linear correlation with the ventilation, that of the PCO2, right? Straight graph. Now, if I ask you, there are both the things. That means type 2 respiratory disorder is there. That means hypoxia with hypercapnia. Whenever one thing is clear, hypercapnia is there. Hypercapnia is what? Increase in the PCO2. Right? Whenever there is a hypercapnia, what will happen? There will be increase in the ventilation linearly. Increase in the ventilation linearly. Fine, we know that, right? Now, if I say that not only the PCO2 has been increased, but also with that, the partial pressure of oxygen has been reduced, right? The graph just now we drawn in the black color. Over here, I'm assuming that the partial pressure of oxygen is 100 mmHg. That means there is no hypoxia, only hypercapnia we took into consideration. But in the second scenario over here, this was the first scenario, this is the second scenario. In the second scenario, I'm saying that there is not only the hypercapnia but also the hypoxia. Then what will happen to the curve? Remember, the apneic point will not shift, but let's take the purple color. What will happen? That the slope of this curve will increase. The slope of the curve will increase whenever there is hypoxia with hypercapnia. All right. So how the graph will look like? The graph will look something like this. All right. So give me a minute. So the graph will look something like this. Okay. Even more hypoxia, the graph will look something like this. Now what will happen, that if there is a hypoxia and severe hypercapnia, what will happen, that the patient will never go in the let's say chronic hypoxia and hypercapnia is there, some restrictive lung disorder is there, severe fibrosis is there chronically, right? Then what will happen, the apneic point will never reach, right? It is indeterminate depending on how much is the respiratory rate, depth and other conditions. All right, so this graph will not reach to the apneic point. It is indeterminate. But if I say that there is third scenario, I'll take, if I say in the third scenario we do have acidosis in the patient. Now what will happen? If there is an acidosis in the patient, the apneic point will shift. Altogether the apneic point will shift. Okay, let's say only acidosis is there, and we are, of course, this is the correlation of the PCO2. So the only acidosis is there. What will happen? There will be shift in the apneic point. Right? If I add on the increase in the PCO2, the graph will be having two changes. First change will be increase in the ventilation, which is going to be there, and shift in the apneic point. So this is the point where the you can see the apneic point will shift. That means the apneic point will shift in the left hand side. All right. So if I draw the graph of increase in the PCO2, it is going to be parallel to that of the black color graph which we have already drawn in the first go, right? And if I say with that if we have decrease in the pH, increase in the PCO2, as well as we do have decrease in the partial pressure of oxygen, then all these three things combined we are going to see, right? So over here what happened? Increase in the slope of the graph, but apneic point was same when the hypercapnia hypoxia together occurred, right? So over here we are going to combine the second point and the third point when we are talking about this scenario all together, right? So what is going to happen in all of that changes? What will happen? Let's assume over here PaO2 is 100 mmHg. Let's say this is graph X, right? Or let's say this is graph A. All right. Now if it is graph B, C, D, now what will happen, that let's say PO2 over here is 60 mmHg, hypoxia is below 60 mmHg of partial pressure of oxygen, right? Let's say 50 over here, let's say 40 over here, arbitrary numbers. All right. Now if I have to draw the same graph with acidosis, then what will happen? See over here, the graph B will be parallel to this graph. Let's say this is the graph. All right, then there is one more graph, right? And there is one more graph. Okay, now let's say the graph A is going to be parallel to P, right? Then Q, R and S, right? So the graph B is parallel to Q, graph C is parallel to R and graph D is parallel to S. Now what will happen? If there is hypoxia, hypercapnia with acidosis, everything is going to shift towards the left hand side. Just remember, whatever they have asked, if the question is mentioning acidosis, everything is going to be the same. The first point and second point, if you understood, everything is going to be same. It's just that it is going to shift towards the left if there is acidosis. And guess what? They have shown one diagram over here. It's not given a proper hint that what is going to happen. But remember, in the INI CET 2022, this question was asked and they have given the same graph, right? This graph was given and instead of writing 40, 50, 60 over here, they have written XYZ, right? And the answer was there in the graph itself, that in the acidosis what will happen. Please remember, only one graph was given in the brown color and the student had to identify which was that graph, and the question was about the acidosis. So of course the graph is going to be having answers sometimes, right? So this is what the summary is, if you want to write. And if I have to answer this question over here, then see over here what is happening. They are saying that the acidosis is there. They haven't mentioned that there is decrease in the partial pressure of oxygen. So we are going to mark the, you can say, the diagram which is parallel to x-axis, right? Or x graph, you can say, right? So this is going to be this line. So answer over here becomes option C. Answer over here, very good, very good. So option over here is going to be option C. All right. So I hope you understood this graph and I hope everything is clear over here, right? So acidosis means shift towards the left hand side. Very good, very good. So shift towards the left hand side. If you have any doubt, let me know, right? So this is the graph and this is the summary. If you have increase in the PCO2 in this type of graph, the graph is going to have the linear correlationship to the ventilation. Second, if with the hypercapnia we are having hypoxia also, increase in the slope will be seen. That means the curve is going to be more steeper, right? And if there is decrease in the pH, of course the overall you can say the combination is going to shift towards the left hand side. So acidosis means apneic point is going to be shifted, right? What is apneic point? The point where the apnea occurs, and this is the point of the partial pressure of carbon dioxide. And normally how much is the partial pressure of carbon dioxide at the normal healthy person apneic point? That is going to be 37 mmHg. I hope you understood this graph. That is all from my side. If you have any doubt, do let me know in the comments. And if you want me to discuss any particular graph, let me know in that comment also, or in the Telegram group. We are going to discuss that graph also. All right. So that is all from my side. Good night. Take care and bye-bye.